My name is Pang Chen. I'm a principal architect in VMware's global cloud practice, and today we're going to give you 10 easy steps to build an enterprise hybrid cloud. That's about all my cheerleading skills are. The session is titled Building an Enterprise Hybrid Cloud for Dummies, but I've had some people come up to me and tell me that this session is titled potentially offensive because who would come into this session, and be called dummies, right? I mean, how can you all be called dummies? So I've had to add a couple of words to the session title. Hopefully that's more politically correct, because I know you guys are all intelligent architects, and I respect your time. You're quite busy. So this session is intended for vSphere architects who may or may not know vCloud Director, and more importantly, may not know how to put all the pieces together to form an enterprise hybrid cloud architecture. So before we begin, I assume that everyone here understands vSphere, correct? Everyone, show of hands. You all know vSphere? If you don't know vSphere, it might be just a little bit higher for you, but we'll move along. This is our EULA for this session, so just mentally click and accept, and we'll move along. So, 3 goals for today's session are, number 1, to understand the constructs of an enterprise hybrid cloud solution using VMware technologies. Number 2, to put that under the context of 10 easy-to-follow design steps in building a vCloud. So we'll call this enterprise hybrid cloud solution using VMware technologies a vCloud for short. And along the way, we're going to address key design considerations. So before we begin with these 10 steps, let's first define what a cloud is, because the term cloud has been used so often, so many places that, some people may not even know what a cloud means. I'm willing to bet that some of you have come in and your boss has told you you've got to build a cloud, and your boss probably has no idea what a cloud really is, other than it's important, right? So a cloud, in its most basic definition, is a style of computing that is simple and abstracted. And it involves 2 key players. You have providers and you have consumers. Providers provide a service that the consumers consume. As a good analogy here, think about electricity providers. As consumers of electricity, consumers don't want to know how the electricity is produced or where it comes from or how it's delivered. They just want that all abstracted. When we turn on a light switch here, we just expect the lights to work, to come on. We don't want to have to worry that, what kind of fuel, whether it's coal or nuclear or solar or whatever is generated. We just want to have reliable service, and that's what cloud is. Just like cloud virtualization was abstraction of physical resources, cloud is the abstraction of the abstraction. We're dealing with higher level objects built on top of vSphere. So that being said, here are the 10 steps I'm going to walk through with building an enterprise hybrid cloud. So the first step is to start fresh. So we've got vSphere resources, and the question is, do we always have to start with a fresh vSphere installation, or can we get by with using an existing installation? Well, you could start with an existing vSphere installation, but as a best practice, we recommend having a brand new, fresh, clean installation for your cloud. And the reason we say that is because cloud is an abstraction of vSphere resources. We've got vCloud Director sitting on top of your vSphere resources, and now vCloud Director organizes these higher-level objects, these cloud objects, and makes requests to vCenter and vSphere underneath you, so you don't have to worry about that anymore. And because of the abstraction, that can be a little messy if you have existing vSphere resources that are running your existing workloads. a good way to think about this is, suppose we have, if you're moving into a brand new house and you expect to have full use of it, but you have no idea that there are people actually living in there, and they're competing for your resources. That's what could happen if you use an existing vSphere installation, because you don't want to have going in there, running vCenter, creating new VMs that are not aware by vCloud Director. So best rule of thumb, start fresh. And here we see the minimum technical requirements for vCloud Director. You've got minimum, which is vSphere 4.0, update 2 or higher, and vSphere Enterprise licensing. And you have recommended, which is what we obviously recommend. You could go with vSphere 4, but we recommend going with vSphere 5 to take advantage of link clones, which enables the fast provisioning in vCloud Director 1.5. We also recommend Enterprise Plus licensing because that has the distributed network switches, which enables you to have more advanced networking options in your vCloud. So as we architect all this, it's really, at this level, basic vSphere best practices, which is really thought of at two levels. The most important level is keeping your VMs up and running. So you want to make sure that your infrastructure, your host, your networking, your storage, has sufficient redundancy so that your workloads always remain running. A secondary consideration is to make sure that your management and your infrastructure components also have some redundancy, although it's less critical than your VM workloads because, if those pieces come down for a little bit, it's okay. The VMs are still running, but you definitely want to have some layer of protection with your infrastructure and your management components. Otherwise, your ability to access your infrastructure or manage or change things will be hampered. So as we carve up these vSphere resources, an easy way to do this is to create a small management cluster, and that sets up all your VMs that represent the infrastructure and the management components. Things like vCenter VMs, your vCloud Director cells. And then leave the rest of the space for your raw cloud resources. Sometimes we call this the payload. This is the area that the cloud will run in. And it's a nice clean split, and it's pretty clean except for one exception, and that is the vShield Edge appliances. Now, vShield Edge appliances are VMs that get spun up by vShield Manager, which sits in your management cluster, but the edge devices themselves reside in the cloud payload area to protect the networks that are available in the cloud itself. So that's one minor exception. The edge appliances are actually quite small, and they have very little overhead, and therefore they're kind of negligible in that respect. So now that we have all our vSphere set up, the next step is to be a provider. So as a provider, we want to carve up our resources to our consumers. And we generally do this to reflect different characteristics, different performance characteristics, or different capacity levels. Because, quite frankly, not all resources are created equal. And because of that, the workloads also may or may not have the same levels of demand or budget. So here, a popular way to think about this is the kind of the metals analogy, right? You've got your platinum, gold, silver, bronze service levels to match kind of the tiers of services that you're going to provide. So when would you create multiple provider virtual data centers? Well, actually, let me back up. So in the vSphere, you have clusters. In a vCloud, we're going to abstract that, and we're going to create what are called virtual data centers. Virtual data centers are simply just a combination of a vSphere cluster and a data store, or more data stores. The goal here is to abstract these things so that as a cloud consumer, I don't have to worry about which cluster or which host to run my workloads. It's just one virtual data center. And these provider virtual data centers are organized by tier. So we could create one giant one, or we could create multiple provider virtual data centers. So when would we create multiple provider virtual data centers? One thing to keep in mind is currently with vCloud Director, when we associate vSphere clusters with data stores, at this time there is no way to differentiate different types of storage within the same provider virtual data center. So if you have in your environment different levels of storage performance characteristics, so in this example you've got Fiber Channel SAN and NFS, then a best practice is to split that and create two different provider virtual data centers. So you see here provider virtual data center 1 and 2. That's a way to keep your storage characteristics separate. Because what vCloud Director does is when it assigns a VApp, it looks for the space with the most free space using the round-robin algorithm. It doesn't know any better about the different types of storage within a provider virtual data center. So in the third example, there's a big question mark here because if you connect a Fiber Channel SAN and a NFS storage within the same provider virtual data center, your storage is going to vary wildly in terms of performance. So that's big red question mark is a no-no here. You could also create additional provider virtual data centers to allow for room for growth. Some people may just want to create one provider virtual data center, but as you start to fill that up, then it kind of paints yourself into a corner. So you may want to create multiple provider virtual data centers and start them kind of half filled to capacity, and that gives you some room for growth. So once you've set up the provider virtual data centers, it's time to set up the networking infrastructure. So in a cloud, we have networks that really come down to either outside the cloud or inside the cloud. When we're talking about networks outside the cloud, they just simply map to existing vSphere networks that you set up in vSphere. That's pretty simple. Inside the cloud, however, we're in a situation where consumers, they want to be able to create a network whenever they need to. And as an architect, you don't want to have to respond to these requests every single time. So the ideal way is to have a facility that you could kind of set up this giant pool of networks that can be drawn down from. So vCloud Director does give you that facility with these network pools. When we have three options to create these networks ahead of time so that whenever there's a cloud request to create networks inside a cloud, it just automatically, through vCloud Director, pulls from the pool, draws from the pool, and creates networks as needed. The first option is to do that using VLAN IDs to segment these different networks within this giant pool. That's pretty straightforward. You just have to have VLAN IDs, VLAN tags. The one potential downside here is if your network environment has a limited number of VLAN IDs, then you could run into a limit here. The second option is called vCloud Director Network Isolation-backed network pools. And this uses a VMware technology that leverages Mac and Mac encapsulation to create private networks. It uses a combination of vCloud Director and what's built already into the VM kernel of vSphere. So when we provision these private networks, what happens is we add additional MAC headers to the network packets to the frame, and it layers on top and creates a private network automatically for us. The only requirement is an optional VLAN ID for the transport network. So this option, if you do that, the only other consideration is because of the increased MAC headers, in your environment, you may want to increase the MTU size to at least 1524 to avoid packet segmentation because of the increased packet sizes. And the third option is called port group backed. This is pretty straightforward. What it assumes is that you as a vSphere architect or admin will have already created a bunch of network port groups ahead of time. And then vCloud Director will just start drawing down from these network port groups. The third option is straightforward, but it also requires the most amount of work because you have to create all these networks ahead of time to draw down from, whereas the other two are leveraging some automation from the vCloud Director. So as a best practice or a recommendation, we tend to recommend the one in the middle, the vCloud Director Network Isolation Back, just because it requires the least amount of upfront work, and it's quite flexible. So once we have that set up, in terms of our provider virtual data centers and our networking, it's time to recruit our customers or consumers of our cloud. So this step, for some of you, you may want to do this as step 1 rather than step 4 if your consumers are the ones funding your cloud project. But this step is important because you want to make sure you have the requirements to build a purposely built cloud for your consumers. So who are these consumers? Today, we really have two main vectors driving the adoption for cloud. We have the need for agility, and we also have some interest in governance. The need for agility is quite prevalent and obvious when you see many developers who have requests for IT systems, and either they can't wait or they've taken matters into their own hands and they've run into public clouds. So these are the types of people who have a lot of requests. It's an urgent request, or they have a temporary request. They need something quick and up and running really quickly. And these are ideal candidates for a vCloud because it borders self-service provisioning. You know, if they could just have access to whatever they need to do their work, then they'll get out of your hair and you'll get out of their hair. So in some ways, this is kind of what, as an IT group, you want to create an area and just let them play in that sandbox and they don't have to worry about you anymore. On the other end, there's an aspiration for governance. And with that, the goal is to try to get to achieve higher levels of higher economies of scale through better management. With virtualization, we've seen how we've increased utilization by sharing resources. But we're at the point now where all this combined consolidation has started to create some kind of turf battles. We have multiple users or tenants complaining about sharing resources, or maybe one tenant is complaining that they don't want to pay for other people's resources, or there's some questions about compliance. Do I have access and visibility into other people's resources? So with that, we want to instill some discipline. Think of this as kind of applying laws in what was previously the Wild West of virtualization. And hopefully these laws and policies will now achieve better economies of scale because we have some better management and orchestration here. So now that we have our consumers, let's define our consumption models of how these consumers will use the vCloud. When we carve up a cloud, our unit of tenancy is called an organization within vCloud Director. So each organization contains users, and the organization has users exclusively to that organization. Those users do not see other users in other organizations. It's kind of, they're in their own little world. They typically map to different lines of businesses. And when we carve up, earlier we carved up the provider virtual data centers to represent our services that we offer to our consumers. When consumers draw down from provider virtual data centers, there's a construct called an organizational virtual data center. So you first, when you create an organizational virtual data center, you first pick your provider virtual data center that you want to draw down from, but you also have an option to specify how the resources are allocated to your consumers. In the default case, if you do not know how your consumers are going to use the cloud resources, then it defaults to what's called pay-as-you-go. So literally, the resources are not reserved until the VApps are created and provisioned. Otherwise, it's just open for everybody. On the other hand, if you have some VApps that require dedicated resources, think of the business-critical applications, for example. We want to fully guarantee their resources. We can give them a reservation pool. It gives them the full amount, typically, even though we may not end up using all of the resources guaranteed. So in the graphic here, you see the actual and the guarantee. You always get that amount. We pay for that amount. And this should typically come with a premium because you're paying for a lot of resources even if you don't use all of them. And you want to charge a little higher for this because you don't want to encourage everybody to want to have reservation pools. Otherwise, it can get really expensive. So as a compromise, we have something in the middle called allocation pool, which in some ways, think of it as kind of reservations done right from vSphere. This is where we give a partial guarantee for resources, but we allow the consumers to use more resources than that guarantee, but those additional resources are in this overcommit range, and that range is shared with other organization virtual data centers. So you get a minimum guarantee, but you also have the ability to kind of increase or burst your capacity as necessary. And you can generally convince consumers to go with this compromise model if you charge them fairly. If you give them a break compared to the reservation pool pricing, they'll go for that, but it's nice to know they can exceed their guarantees as needed. So visually, this is how things would work. At the top, you see the pay-as-you-go model. Everything's unreserved until we start creating VApps. At the bottom here, you see how allocation pools and reservation pools can work together. You've got allocation pools that each have their own guaranteed areas, but then what's in green is shared. So it's kind of first come, first serve. Whereas the reservation pool on the left, it's completely dedicated to the organization virtual data center. One takeaway here is that you don't want to mix pay-as-you-go with the other two, with the allocation pool model, because in that case, you may assume that you have access to these resources, but in contention moments, you actually may not because they're bursting beyond the needs. So now that we have our resources defined, let's define our catalogs. So the idea here is rather than giving everyone the ability to build custom applications, we want to try to drive them into a standard set of services. One way to think about this is think of running a restaurant. If you had diners come in, they could order items individually, and you'd have to make each item to order, and that'll take time to fulfill. But what if we gave them a shortened menu with just a preset list, maybe only 5 items from our larger menu? You see these sometimes as lunch specials, but now we can offer a smaller set of items that are priced lower because most of these items we can give them a break because we've kind of pre-allocated some resources already into making these. So with this concept here, we're trying to steer consumers into a standard set of services, a standard set of VApps that they can just pick and choose from that fits most of their use cases. And by doing this, they can provision these very quickly rather than having to wait for things on demand individually. So each organization can have its own catalog, and the catalog consists of VApps and media. As you architect this, you may discover that you may have some items that start reappearing in each organization across your cloud. So you could do that, but that might result in a bunch of redundant or duplicate catalog items. And a better way to do that is to create what's called a master catalog. A master catalog that contains kind of a universal set of items that everybody uses. Maybe they're base VApps or base operating systems. But when you create a master catalog, in vCloud Director, an organization has to own a catalog. So we'll also want to create a master organization to hold this master catalog that's visible to all the other orgs. If we put in this diagram, if we put the master catalog in org A, that would be a little weird, because what happens if later on org A disappears? Then B and C don't see this anymore. So you want to have a master organization that's just kind of like a system level org to hold this public catalog for everybody. So we're up to step 7 now, which is let's define some controls for access and policies. So at the cloud level, we've got a system administrator, which you don't see here. But then once we set up the cloud, for each organization, we have these various roles to administer that organization. At the highest level, you have an organization administrator. And then you can also have catalog and VApp authors if you want to have some more finer control of responsibilities. And at the bottom, you have your typical VApp users. Or you could even get more extreme and limit just the access to only the consoles of the VMs. So those are all the roles that come with vCloud Director. Then we can apply these quotas and leases. This is really great in the cloud world because now we can enforce some expiration dates. Think of this as like freshness dating. The problem is that in virtualization, everyone's there, they're using VMs, and they get either lazy or forgetful, or they get protective, but they run a VM, and then it just sits there, and people forget about it. With a quota, you can control how many resources users can use, but the most important thing is with leases, you can set an expiration date. So when that time comes up, that VM will expire. So it'll automatically get deleted and frees up resources for other consumers. Now, if consumers had forgotten about the leases, the VMs, they can always go and extend the lease, but at least it keeps them on their toes. So we're up to step 8 now, provide networking. So earlier we talked about networking outside and inside the cloud. Outside the cloud, it just maps to an existing vSphere network port group. Inside the cloud, we have these layers of options. At the most basic building block, we've got VMs. And VMs, in turn, comprise VApps. And you have 2 layers of networking. You can create VApp networks that are networks within a VApp, and you can have networks that are within your organization. And with these 3 levels, you can create very simple or very complex networking hierarchies. Each VM can connect to a VApp network or an organization network, or you can have the entire VApp connect to another VApp network or an organization network. Think of your different, like a multi-tiered application where you have certain VApps, certain VMs in the VApp that need to talk to each other or need to talk to other VApps or to the outside. And in vCloud Director, when you provision these networks, you have an option of what's called either direct or NAT routed. And when you see NAT routed, it shows up, it pulls up a vShield Edge appliance automatically for you. So you see that little Edge device there. So when you choose NAT routed, it automatically spins up an Edge device that provides these additional capabilities on the network, these services. There's firewall, NAT, DHCP, port forwarding, IP masquerading. There's an additional capability within vShield Edge that facilitates site-to-site VPN, but that requires the full vShield Edge license. Everything else above it comes with the vShield Edge license that comes with vCloud Director. So at this point, we've created enough for our cloud environment, and we want to take a step back and validate the provisioning steps. So provisioning really involves 2 groups. One is kind of the setup by the admins in the org. We need to be able to compose and manage these VApps. This is typically done once to create the VApp, and then you may go back to maintain the VApps as needed. And then once you do that, then the consumers are free to deploy these VApps from the catalog whenever they need to. So it's kind of build once and let them consume, and we're ready for business. So in building the VApps, here are your options. First, you create the VApp, you give it a name, and you designate which organizational virtual data center to run it in. And then for each VM, you specify the host computer name of the VM in the guest. You also specify some networking options, which network to assign it to, the IP assignment scheme. And you can get a little more complicated. You could actually choose this fencing model. Fencing allows, kind of creates a wall around VApps that allows communication in and out to be filtered, so that you can potentially create a wall around a VApp so that they can see outside, but the outside cannot see in. And that might be great for testing purposes. So once you've set this up, then we're in business. We've got a cloud with standard VApps, and from the consumer's perspective, it's quite simple. It's just these steps. You go to your catalog, you pick a VApp template, you provision it, and it goes to an organization virtual data center, and you choose your networks. And then we got cutesy, and we put this in an area called My Cloud. But from a user perspective, this is the portal that they use. There's a link to add a new VApp template, and then it creates this VApp here with the console access and your power functions. So at this point, we have everything ready for a private cloud. We could just leave it there, or we could connect to a public cloud. So why would we want to connect to a public cloud? Sometimes there are certain reasons that we may want to burst to a public cloud. A lot of times it's maybe a need, an urgent need, or a temporary need, or a seasonal need for resources that we don't have today. Or maybe we have done the math and we've calculated that some workloads may be more cost-effective to run in a public cloud. Keeping in mind that there are sometimes compliance reasons where we may want to keep our existing workloads running in our private cloud. So in this diagram here, we can have the best of both worlds. And what's the key to a hybrid cloud? It's compatibility. And compatibility involves OVF in the middle. So the open virtualization format, this allows us to move a VApp freely between both sides. And we also want to make sure that we've got vCloud Director and vSphere on both sides, on our private cloud and our public cloud. And in this picture, this is how we move VApps. The tool to use is vCloud Connector. vCloud Connector allows us to move a VApp pretty seamlessly, although today the functionality is only for powered off VApps. So all the VMs have to be shut down ahead of time to move over there. So in the future, this will become really powerful when we get to the capability of having running workloads burst to the clouds, to federated clouds. But for today, you have to shut down the VApps. And then when you move the VApps over, the format's all taken care of for you, but when you bring that up, you'll need to think about the networking, how it could be different on the destination cloud from your source cloud. And as you move to the public cloud, you may also want to consider site-to-site VPN capabilities to talk back to your private cloud, which earlier we talked about vShield Edge in the fully licensed version having that capability. So there you have it, 10 quick and easy steps for building an enterprise hybrid cloud. Some bonus considerations. If you want to create a more robust cloud, you can add chargeback. Chargeback kind of touches on the governance needs. So it's integrated with with vCloud Director, and it can take the usage information to help give more clarity into the usage pattern to drive the usage behavior. If you need more governance in the provisioning, we have VMware Service Manager. This allows us to provision workflows through a defined workflow process that you can integrate approvals through. And that talks through a new connector, a VMware Service Manager connector to vCloud Director using the vCloud API. If you need more automation within some of the components in your cloud or to external systems, we have, don't forget, vCenter Orchestrator that is included in free with vCenter. And this allows you to orchestrate and automate at the Vim API level, the vCloud API level, or through other third-party plugins. And the last piece here is the vStorage API for data protection, which we have worked with our third-party backup application vendors to create solutions to back up vCloud Director provision VApps. So visually, here are how all the pieces integrate in this puzzle diagram, all the pieces that are connected and integrated with the vCloud Director. You see vSphere, vCloud Director in the middle, and all the pieces around it. At the bottom here, I've got a couple of components that are not yet vCloud Director aware. So we don't have the integration yet. They are on the roadmap. The two main ones are vCenter Ops and vCenter Site Recovery Manager. So it's not to say they won't work in your environment, but they only at this time talk to vSphere directly. So you're getting usage stats from at the vSphere level for vCenter Ops, but vCloud Director is not aware of that because all that information is in its own separate database. Similarly, with Site Recovery Manager, you can use SRM to restore an environment, but some of the higher level constructs we talked about earlier, that's in the vCloud Director, are not visible on the SRM side, and we expect integration probably by next year. So hopefully that's given you kind of an idea of what constitutes a VMware Enterprise Hybrid Cloud and the 10 steps to build this and some key considerations along the way. So before I open it up for questions, I've got some obligatory promotional announcements. Make sure to visit our partners here who have the vCloud API integration. There's also a stack of other cloud-related sessions outside the door that you can look at. Don't forget to rate this session. Please don't penalize me. And with that, we'll open it up for questions. We've got some mics right there. Was it that simple that you have no questions? Are you all dummies, huh? Yes. Okay, so the question was changing the MTU size. So if you're using the vCloud Director network isolation-backed option for your network pools, we use Mac and Mac headers, and we add additional headers to the frames. So the packet sizes are going to get larger. In a typical network environment, the default is 1,500. The additional frames needs to have 1524. So if you don't bump up that in your switches, then you can have the risk of packet segmentation and fragmentation, and that might slow things down a little bit. So just make sure to up the number to 1524 at least for performance reasons. Okay, question?
What's the number of management servers that you need per the number of payload servers?
So the question is, what is the number of management servers you need for the payload? So the question really is twofold. One is, it's a factor of vSphere, right? Scale your vSphere for your VMs. For vCloud Director, we want to have at least redundancy, so at least 2 vCloud Director cells. They sit behind a load balancer. They're not clustered in the sense that there's availability. It just uses load balancing to redirect. So think of them as nothing more than like web servers. So at a minimum, you want 2, but there are some kind of limits that we publish in the documentation on the number of cells to vCenter servers to hosts. But in general, the sizing is really a function of your vSphere sizing. So the question is it linear as you scale? I think so. Okay, question?
How hard is it to add So if you're starting out without using load balancing, how hard is it to add load balancing later on? So say, for instance,
So the question is, if you just start out with one vCloud Director cell, how hard is it to add load balancing later? It's really not that hard. Once you've set one up, the second time you set up a vCloud Director cell, you'll need to point to that and just make sure your load balancing sets up accordingly. But they all talk to the same database.
Okay, so when you start off, you want to make sure you build your first cell using the NFS SharePoint like you were setting up a multi.
Yes, so there's another point here. When you have multiple cells, it does require an NFS SharePoint to facilitate transfer of files between the cells. So the first one will point to that, and there's an additional step. I believe there's a KB article that talks about how to reconfigure additional cells to point to that so you don't have problems with that setup. Sure, keep going.
One more. When you're rolling out machines, we participated in the vCloud Director 1.5 beta, and the name of the VM, if you look in vSphere, is like some long, it's like a unique ID. Is that ever going to change where it'll actually show the ID of the VM, or will it always be in that long?
So the question is, when you look on the vCenter side, VMs that are provisioned by vCloud Director has this really long name. There is the Cloud EU ID that it uses, and I believe it's still going to continue using that for the time being. That has not changed in the new 1.5 release. Okay, thank you. Yes?
So let's say currently we have a lab manager infrastructure set up. So is there a way we can leverage this infrastructure into vCloud Director?
Okay, so the question is, if you're running an existing lab manager infrastructure, how does this compare to vCloud Director? Unfortunately, they are somewhat competing. Lab manager was, what we created many years ago, and in some ways, if we had called it Cloud Manager, we would have won the war with cloud. But we took some of the lessons learned, and we have built a new multi-tenant-oriented platform called vCloud Director. So there are similarities with 1.5. We've added the parity with link clones and so forth. But Lab Manager at this time, it hasn't been like it's officially, unofficially announced, but basically it's end of life. It'll continue running for 1 or 2 more years, but at this point, there is no tool that is available to migrate your Lab Manager workloads into vCloud Director. What you could do is you could export the VApps out to VMs and then import them, but right now they're just kind of separate. Lab Manager also only works with vSphere 4. It will not work with vSphere 5. Right?
All right.
Yes. Yes. So the question is, if you don't start fresh and you use an existing vSphere installation, is there any way for vCloud Director to learn what's already there? Not really. I mean, it knows what's there, but at the same time, it's managing all its VApps and its VMs, right? So it creates things. But the danger there is you don't want to be running that and then going into your vCenter and continuing to add VMs. That's the problem, right? Because now you've got this dueling war. It knows that the VMs are already there, and it will take into account, especially if you create the clusters and the resource pools. As long as you carve yourself out an area, you're fine. In fact, in a provider virtual data center, you have the option to do either vSphere clusters or resource pools. We don't typically recommend resource pools because it's flexible. If you have a cluster with only so many hosts or only a few clusters, resource pools work. But there's always a danger to hang yourself, right? Because if you do resource pools with expandable reservations, the goal here is you can't have more than what you have there, right? That's the trick. Yes. Question?
I've got one. This is probably a dummy question, but can vCloud Director manage bare metal? And if not, are there any plans?
I'm sorry, could you say?
Can vCloud Director manage bare metal resources?
Can vCloud Director manage what resources?
Bare metal servers.
Bare metal resources. No, because vCloud Director abstracts vSphere, which abstracts bare metal, right?
Are there any plans in the future? All the OEM vendors provide free APIs for that.
So are there plans? There is the vCloud API. So that's how we integrate with the rest of the world. So I think if you're looking for an all-encompassing solution that talks to your bare metal things and then your vSphere things, that's kind of how the APIs meet in the middle. Right. Okay. Question? Yep, so the question is, do VApps provide post-provisioning scripts? Yep, just like guest customization, there's a pre- and a post-customization script that you can launch automatically. Okay, well, thank you so much. I'll give you back 10 minutes of your time. I'll be up here if you still have questions. Thank you.